Now that we have determined the position of the vertical centroidal axis of the figure, we will determine the moment of inertia about this vertical centroidal axis of the figure. We will have to apply the parallel axis theorem, and to solve this problem we will make another table. We have to determine moment of inertia about vertical centroidal axis, so that is your IYY. Our table will be section, moment of inertia of section about vertical axis, area, and h, which will be x bar minus x. We have 4 sections. So section 1 is our right angled triangle. Now for this right angled triangle, we know IYY is given by BH cube by 36, and your base is 50, height is 120. So BH cube by 36 will be 2.4 into 10 to the power 6. Second section we know is a rectangle. We have considered rectangle to be our second section. For second section, IYY will be BB cube by 12. For IXX it is BB cube by 12. For IYY it is BB cube by 12. Your depth of the section is 120 and base of the rectangle is 200. So the IYY comes out to be 8 into 10 to the power 7. Then we have third section. This is our third section. Again, a right angle triangle. For a right angle triangle, you have BH cube by 36. Its value is 2.4 into 10 to the power 6. And our last is your semicircle. For semicircle, its moment of inertia about vertical axis is given by pi by 128 d to the power 4. Our d is 200, so pi by 128 into 200 to the power 4, it comes out as 3.9 into 10 to the power 7. Let us write the areas. We know for section 1 the area is 3 into 10 to the power 3. For section 2 it is 2.4 into 10 to the power 4. Again for next triangle 3 into 10 to the power 3, and for semicircle it is 1.57 into 10 to the power 4. Now important part, we have to determine the h. We know our x bar is 153.84. We know our x bar is 153.84. So for first section we have x bar as 153.84 minus first section ka x is 33.33, right? So minus 33.33, it comes out to be 120.4. Okay, approximately 120.4. For second section again 153.84 minus second section ka x bar is 150. So this is minus 150. This will be 3.84. For third section 153.84 minus the second section x is 266.67. So 266.67, this is in mod, so you will get another a positive value of 112 point something. And for last section we have the value of x bar as 150 and our universal x bar is 153.83 or 84 minus 150 will give you 3.84. Okay, and we have the formula to determine IY as IYY plus AH square for section 1 plus IYY plus AH square for section 2 plus IYY plus AH square for section 3, and the the semicircle we need to deduct, so minus IYY plus AH square of section 4. I will repeat how we determined the h value for vertical centroidal axis. We had the location of vertical centroidal axis for the entire figure as 153.84. We know that this particular right angle triangle, the vertical centroidal axis of this right angle triangle is lying at 150 from this, and this is 153. So we determined it, sorry, 33.3 from this, and this is 150. So 153 minus 33. For a rectangle, it was lying at 150 and this was 153. So the distances between the vertical centroidal axis of the rectangle and vertical centroidal axis of this entire section was 153.83 minus 150. Similarly, we solved for this right angle triangle and this semicircle. This is how you're supposed to solve a problem in which using parallel axis theorem. Thank you.